Hello everyone. In this lesson, we're going to learn how to solve equations with variables on both sides. So for our first example, we'll start off with something just basic, so no parentheses in these examples. So what we want to do for these is to solve for the variables. So here in part A, we're solving for x. And so the problem is now that x is on both sides of the equation. So we have to figure out what would be the most efficient and simple way to get x on one side of the equation and everything else on the other side. So first of all, let's go ahead and try to get x's on both sides of the equation. So the rule of thumb here is to always move the smaller x. Always move the smaller x. And that would include the negative sign that would be in front of it. So for example, you might think at first that 4 is smaller than 8, but you have to look at the sign in front of the 8. Since actually negative 8 is smaller than 4, we're going to move negative 8x onto this side. Since it's negative, we will add it. So plus 8x plus 8x. So then on this side, we're left with 7 equals 4x plus 8x makes 12x minus 17. Okay, after that, we have a problem just like we did in the last lesson. So now all we need to do is add the 17 and divide by 12. So now all we have left is a two-step equation. So plus 17, that makes 24 is equal to 12x. So then x is equal to 2 if you divide both sides by 12. All right, let's look at part B. So looking at the m's, you have negative 3m and 5m. So which one would be smaller? And which one will you move? You're going to move the negative 3m since negative 3 is smaller than positive 5. So if it's negative, then we will add it. Plus 3m plus 3m. So then over here, we're left with 24 equals 8m. Divide by 8. M is 3. All right, so right now you can pause the video and try these examples. The Edpuzzle will prompt you to answer the questions. Okay, so now if you didn't get it right, I'll show you the right way to do it. Or maybe you did get it right, but maybe I have a few tricks to show you. So here, looking at the c's, we always move the variable that's smaller. 1c and 4c, 1c is smaller, so we move the c by subtracting it, since it's positive. So then you have 20 equals 3c minus 7, and then it's a two-step equation where you add the 7. At this point, you might be able to do this in your head, and that's okay. C would be equal to 9, since 27 divided by 3 is 9. If you can do a two-step equation in your head, then I'm okay with that. Okay, just be careful if you have negative signs, like if the 3c was negative, then you'd have to divide by a negative. Okay, but the way we do it this way, by moving the smaller one over, then your variable shouldn't end up being negative. If we were to move the 4c, then the variable would end up being negative. Anyways, okay, so let's look at part D. So we have negative 3k and negative 2k. So negative 3k is smaller since it's further left on the number line. So we're going to add it. Plus 3k plus 3k. So 9 equals 17. Negative 2 plus 3 is 1. So plus 1k, or just k. And then subtract the 17 over to the other side. 9 minus 17 is equal to negative 8. You can check it on your calculator if you're not sure. All right, so those are the answers you should have gotten. Let's move on to examples where you have grouping symbols. By grouping symbols, I mean parentheses or brackets. Usually you'll see brackets if you have parentheses inside of them. You've seen that with order of operations. All right, so for part A, so the first step is to get rid of the parentheses by distributing. Whenever you see parentheses, you want to distribute what's outside of the parentheses. In this case, it'd be 1/4. So distribute the 1/4 into the parentheses. So 9x minus 5 stays. 1/4 of 16, you can think 16 divided by 4 is 4x. 60 divided by 4 is 15. Okay, and then let's combine the x's. So the 4x is smaller, so we're going to subtract that. And at the same time, you can actually, if you want to, you can go ahead and add the 5 over to the other side. Since we're going to get all of the constants over here and the variable over here. So then you have 5x, or you could just do it in 2 steps. Equals 20, so x equals 4. Okay, for this one, you have a 2 in front of the parentheses, so distribute the 2. Always draw the arrows, because sometimes we get lazy and we stop drawing the arrows, and then you forget to distribute it onto the second term. Especially when we get to more complicated equations where you might have 3 or 4 things in the parentheses, the arrows help you just remember to do all of the multiplication. Okay, so that would be 2 times 3z is 6z, 2 times negative 4 is minus 8. Okay, so which z would we move, 5z or 6z? We're going to move the 5z, so minus 5z, minus 5z. Okay, now careful. When you copy down the 2, you have to include the negative sign in front of it. So the minus sign is going to turn into negative 2 equals z minus 8. That's where most people get their problems from, is when they forget to carry down the negative signs into the next step. Okay, so now we're going to add the 8 to get the z by itself, and then you'll have 6 equals z. All right. Okay, so now you're going to try these examples. So pause the video, try these examples. So for this one, you will distribute the 5. So you have 3 minus 4a. I'm going to go through this a little bit faster. Okay, then we're going to add the 4a. So 3 equals 9a minus 15. Add the 15 over to get 18 equals 9a. Divide by 9. A is 2. Okay, so if you got that wrong, figure out what step you missed. And then this one, we're going to distribute the 2/3. So what I like to do is whenever I multiply by a fraction that doesn't go into a totally evenly, I like to put it over 1, the whole numbers. So we have 8y minus 6 equals, so this would be 12y over 3, and then plus 30 over 3, and then we will simplify the fractions, because 12 over 3 would be 4y, and 30 over 3 would be 10. All right, and then I'm going to move the smaller y, so minus the 4y. At the same time, I'm going to add 6 to both sides. So you have 4y equals 16, so y equals 4. All right. So now we're going to talk about identifying the number of solutions. So we can either have one solution, we can have no solution, or we can have an infinite number of solutions. So we'll try to figure out which one would be which. Okay, so first of all, we will distribute the 3. So 3x equals 3x plus 12. And I guess we'll subtract 3x on both sides since it's the same thing. Okay, 3x minus 3x would be 0. 3x is 0 again, and you get 12. Okay, so 0 equals 12. Wait a minute, that's not true. So we'll say 0 does not equal 12, so which one do you think it'll be? This would be no solution. So whenever you get that a number equals a number that it's definitely not equal to, then that would be a case of no solution. Graphically speaking, these are actually a solution is where lines intersect each other. So if they don't intersect each other at all, what kind of lines are they? They are parallel lines. So parallel lines give you no solution. This is a little symbol for parallel lines. We'll talk about that more when we do the graphing linear equations. So let's try this one. Distribute the 2, so you get 2x plus 10 equals 2x plus 10. Now, at this point, do you see how both things are on the same side of the equation? If you subtract everything out, you're going to end up getting that 0 is equal to 0. So whenever you have that one side is equal to the same side, then that would be what we call identity, meaning it's the same thing, the same line. So you have infinite solutions. So actually the two lines lie right on top of each other. So they intersect at all points because they're the same line. Okay, and then the last example. Okay, so here I would subtract the 7w minus 7w. Okay, so you get 1 equals 1w plus 1, and then subtract 1, and then you get 0 equals w. Okay, so in the cases above, for no solution and infinite solutions, the variable cancels out. If the variable doesn't cancel out and you get that the variable equals some number, whether it be 0, a negative number, a positive number, or whatever number, then that's actually a solution. So we have a solution here. So there's just one solution. Graphically, this would be an example of where you would just have two lines and they intersect at one point, right there. Okay, so this would be an example of just one solution. Okay, and then we have a word problem. So let's try this word problem here. Car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. So number of new cars, okay? And then they originally sold 78 new cars. The number of used cars sold has been decreasing, so decreasing for the used cars by 4 cars each year. If these trends continue, how many years will the number of new cars sold be twice the number of used cars sold? Okay, so we're trying to get an equation where the number of new cars sold is equal to twice the number of used cars, so 2 times the number of used cars. Make sure you pay attention because there's going to be an example like this in your assignment. So let's write an equation for the new cars. Well, first of all, you always start, well, not always, but it's good to start with the amount that you start with, so 78, and then you're increasing, which means plus 6 cars each year. So 6, how about let's let x equal the number of years. And then equals 2 times, the same thing for used cars, except we're decreasing. You start with 67, and you decrease by 4 cars each year. So now we're going to find x, which is going to represent the number of years, the number of years that the new cars will be twice the number of used cars. Okay, so let's go ahead and solve. So let's distribute the 2. Distributive property first. This would be 120. 2 times 7 is 14, so that would total 134 minus 8x. So mental math there. Add the 8x. and subtract 78. So you get 14x is equal to, this would be 56. Divide both sides by 14, and you get x is equal to 4 years. So in 4 years, the number of new cars sold will be twice the number of used cars sold. All right, so then for your exit ticket for tomorrow, you're going to do a problem very similar to that, except with music websites. So make sure you pay attention and have all this whole equation written in your notes, so that when you get to this exit ticket tomorrow at the beginning of class, you will know what to do. Okay, and there will also be more questions like this on your exit ticket where you determine the number of solutions. So if you want, you can pause the video at those points where I'm flipping back and forth and try them out ahead of time. That way when you get to the problems tomorrow, you can just write down the answer. All right, that's the end of the video. Have a great day.